In the world of cybersecurity, there are folks who use tools, and then there are the ones who actually build them. And that's a huge difference. It's like being handed a key versus being able to forge any key you could possibly need. So today, we're going to crack open the Hacker's Workshop and dive into Justin Seitz and Tim Arnold's classic, Black Hat Python, to really understand how to build your own offensive security toolbox. It all starts with one single, powerful idea. And this, right here, this is the heart of the whole thing. This quote from the legendary hacker Charlie Miller just sets the stage perfectly. See, it's not about memorizing a bunch of commands for programs that someone else wrote. The real power, the true creativity in hacking, it comes from knowing the fundamentals so well that when you hit a wall, you don't go looking for another tool, you just build one. So what exactly do we mean by Black Hat Python? Well, don't get too hung up on the Black Hat part. In this context, it's really all about offensive security, using the Python language to build your own custom tools for things like penetration testing. It's all about learning to think like an attacker so you can find and fix those weak spots. And this brings up a really critical point. The very same skills, the exact same tools, can be used by ethical hackers to lock a network down tight or by malicious actors to break in. The code itself, it's neutral. The power and all the responsibility that comes with it, that lies with the person behind the keyboard. I want you to think of this like building a digital toolbox, right? Every pro has one, but the absolute best can whip up a specialized tool on the fly to solve some unique problem nobody's seen before. And that's exactly what Python lets you do. We're going to look at a few examples right from the book, each one a little more clever than the last, to see exactly how this works. And wow, the arsenal you can build is seriously impressive. Just look at the range here. Everything from simple network sniffers that just watch traffic, all the way to advanced stuff like using GitHub for command and control or escalating your privileges on a Windows machine. Python's versatility is what makes it so perfect for this kind of work. It is a true workhorse in the security world. Okay, let's kick things off with a classic scenario. Imagine this. You've done it. You've gotten a foothold on a target system. You go to reach for your most basic, most essential networking tool, and it's not there. The sysadmins were smart. They removed it. So what do you do now? The tool we're talking about is Netcat, and it's called the Swiss Army knife for a very good reason. You can use it to move files, open up remote shells, scan for open ports. It's just incredibly useful. For a pen tester, finding that it's missing from a system, that is a major roadblock. So, what's your next move? Do you just pack it in? Hope some other tool might be lying around? Or do you remember that core principle we started with? You build your own. That's the beauty of Python. Using just the standard socket library that comes with it, you can write your own little version of Netcat in a surprisingly tiny amount of code. And just like that, you're not stuck anymore. You forged your own key, and you've just unlocked the door. Okay, so replacing a missing tool is one thing, but what if you want to become a sort of digital wiretap? To sit right in the middle of a connection and see, or maybe even change every single thing that flows through it? Well, for that, you build a TCP proxy. It's actually a pretty simple idea. Your Python script just sits right in the middle of the conversation. The client computer, it thinks it's talking directly to the server, and the server thinks it's talking directly to the client. But the truth is, they're both talking to you, and you're just passing the messages back and forth. And because you're that person in the middle, you have total control. You can log all the traffic, you can inspect it for juicy details like passwords, or you could even modify the data as it's flying by. This is an absolutely powerful way to reverse engineer how things work, or to find vulnerabilities in an application. All right, let's level up and look at a more advanced technique, creating secret passageways right through a network. A lot of the time, the first machine you get onto doesn't have access to the really interesting stuff. But you can actually use the encrypted SSH protocol to build these tunnels that sneak right past firewalls and let you move deeper into the network. So let's walk through this. On the left, you've got your machine, the SSH client. And way over on the right, behind a firewall, is the web server you want to get to. Using forward tunneling, you tell the SSH server you're connected to, hey, create a secure tunnel for me. It then links a port on your local machine, say port 8008, directly to the web server's port 80. And here's the magic. Now, when you connect to your own computer on port 8008, your traffic gets securely zipped through that tunnel, bypassing the firewall, and connecting you straight to the target. But reverse tunneling, now this is even more clever. What if the machine behind the firewall can't accept any incoming connections, but it can make outgoing ones? No problem.
With a reverse tunnel, you get the compromised machine to connect out to your server, and in doing so, it opens up a tunnel back into its own network for you. It's basically like tricking someone inside a castle into lowering a rope ladder for you to climb up. And this right here is a fundamental concept in penetration testing called pivoting. It's the art of using your first foothold on one machine to jump over to other, more secure machines on the network. This is a total game changer because that first machine you compromise is almost never your final destination. It's just a stepping stone. Tunneling is how you leap from that stone to get to the crown jewels, the really sensitive stuff hidden deep inside the network. And that brings us right back to where we started. Netcat, proxies, SSH tunnels, these aren't just tools. They're solutions to very specific problems. And the ability to look at a problem, to really understand it at a deep level, and then write the code to solve it, that is the skill that separates the amateur from the professional. This comparison really gets to the heart of it all. If you only rely on pre-made tools, you're stuck with their limitations, and you're pretty easy for security software to spot. But when you write your own stuff, the only limit is your own creativity. You can invent completely new methods that no antivirus has ever seen before, because you literally just made it up. It's a fundamental shift in mindset, from being just a consumer to being a creator. And that kind of leaves us with this final thought. A tool that can test a firewall's defenses is also the tool that can bypass it. A script that finds a vulnerability so it can be patched is also a script that can exploit it. This knowledge is incredibly powerful, and it's also neutral. So the ultimate question isn't just about what you can build, but what you choose to do with that knowledge.